week number 5. I cannot believe it. We have made so much progress in our online classroom. This week, you may have noticed that this is an extra long video, and that's because there's one video for the week. So there's timestamps, and that just means that there's a timestamp or a number of time when each day starts. So if you look in the email I sent you, or if you look in the description below this video, I'll have it all labeled. So Monday starts at this time, and you should just be able to click the time and it'll take you to that time. Hopefully this will ease a little bit of confusion finding all the different videos, so we'll see if it works. This week, I really want to emphasize the importance of completing your work. Make sure you take advantage of that Zoom office hours that you can get on using my link in the email from 2 to 3 o'clock, and I'm just waiting there. I've had very few students take advantage of it, so if you have questions, make sure you're jumping on and asking those. I just want to let you know that I miss you. This has been a long time, and it's really hard to teach without seeing your students, and I'm sure it's not easy learning without seeing your teacher either. So hang in there. We're getting close to the finish line. Don't give up. Please don't give up. Get those assignments in if they're missing, if that's still a possibility. If you're not sure, email me and ask me, and you can get that done. This week, in your first submission, I would love to hear the high and the low of your last week. One thing in this online platform is we don't have much interaction about our personal lives. Usually right before the bell rings, we kind of talk about what everyone's up to, what they're doing this weekend, and I know nothing about what's going on with you, and I'd love to know about it. So if you want to, when you submit your Monday assignment, share your high and low for the week. Again, that's not a requirement. I'm not going to make you tell me stuff about yourself, but it would be fun to hear what is going on in your world. So without further ado, let's jump into Monday. Have a good week. All right, welcome to Monday. We're going to start off with our first graphing method of the week. Graphs are all about taking information and making it visual, so when someone looks at it, they can immediately see what's going on. So we are going to start with pie charts. With pie charts, we are only going to be reading them in this class. Now, we could learn how to create them. In a circle, there are 360 degrees, and so we could break that off into chunks and draw our pie charts, also known as circle graphs. But we are not going to do that. I will let you know Excel is a great resource to create those. So in the future, when we're working on a project, if you'd like to create a pie chart, that would be an excellent resource. And I'll give you a link when we get to our project next week if you want to learn how to do that. So looking at this pie chart, first of all, you'll notice I wrote all over it because I had to print in black and white this week, and so you couldn't see any of it. So I apologize for that. In color, it looked great. In black and white, not too much. So let's see what's going on. First of all, I read the title. It says funds raised for mission trip in hundreds of dollars. Okay, so in January, they didn't raise just $2, right? 200 in February 1, March 4, and so on. So let's answer the question. In which month did the most money come in? So looking at a pie chart, pie charts are great for this. We can quickly see which section is the largest, right? And what section is the largest here? May, so that means in May the most money came in, and they ask here how much. So we can look and we see a 6. Again, it's not 6 that came in, it would be hundreds of dollars, so $600. Number 2, in which month did the least money come in? Again, pie charts are excellent for being able to visually see what's going on very quickly. And what month is that? February. And how much? Again, 1 means $100. Number 3, by how much does the most exceed the least? This one's almost too easy for you guys. By how much does the most exceed the least? Well, we said the most was 600, the least was 100, and it exceeds it by 500. Subtraction, right? Number 4, how much did Jeremy raise for his mission trip? Well, how can we figure that out? If you think you know what you're doing, start working on it. Give you a few seconds to think about it, and then we're going to jump in. Well, if you raised 2 in January and 1 in February, that's 300, right? And we can continue to add around the pie chart. So let's do it. 2 plus 1 is 3. 3 plus 4 is 7. 7 plus 5 is 12. 12 plus 6 is 18. 18 plus 4 is 22. And again, that's hundreds of dollars. So we would say $2,200 or $2,200. All right, that's our first example. Let's move to our second example. Again, some of it didn't print very clearly. Some of it you can see, so I didn't write it all in. So looking here, the first question, which sport is most preferred? Again, these circle graphs lend themselves really well to being able to quickly see what's going on. So right away when I look, I see 2 big sections. This is 21% and this is 25%. Let's backtrack for a second though and read the title, Preferred Sports. And so we have these different sports and the percentage of people that prefer them. Okay, so which sport is most preferred? We would say basketball at 25%. Number 2, which sport is least preferred? Again, we can quickly see the least preferred sport is what? Write it down. Volleyball. We apologize to all the volleyball players out there, but we do know basketball is definitely most preferred, right? All right, number 3, what is the difference in the percents between the most and least preferred sports? So what percent was most preferred? Well, it was 25% from basketball, and the least preferred was volleyball at 6%. And they say difference. Difference means subtraction, right? So we get out 19%. Number 4, what percent prefer either baseball or golf? So what percent prefer either baseball or golf? So looking here, where's baseball at? Right here. 21% prefer baseball and 9% prefer golf. So what would we do to find the ones that prefer one or the other? We're going to add them up. So 21 and 9 give us 30%. And again, these problems aren't necessarily hard. It just takes some analyzing, and that's what we're doing here. So number 5, if the graph represents responses from 100 people, how many of these people prefer football? So first of all, let's go over and look at football. They say that 12% of people prefer football. Okay, so we'll just bring that over here, 12%. And they say if they asked 100 people, and this is what they came up with, and 12% of them prefer football, well, how many people would that be? Well, we should be able to do this mentally, but we'll talk about how we could compute it as well. 12% of 100. How could you find 12% of 100? We learned about this year. When we say 12% of 100, if I write that, what would we do in place of this of here? We would multiply, right? And then you would also remember that you need to change this to a different form. Percent means per 100, right? Per century or per 100. So you could put this as 12 over 100. The way we did it more often was change it to a decimal, right? We would move it to the left 2 times and have 0.12. When we multiply that by 100, it does what? It moves it to the right twice. So 0.12 times 100 gives us 12. And again, I said you could do this one mentally, right? Because 12% of 100 is just 12. We know this is per 100, so it's already of 100, it's going to be 12. All right, let's move down to number 6, similar but a little bit more challenging. Number 6 says, if the graph represents responses from 36, I can't get away without an error. People. It really wasn't that bad. All right. How many people prefer basketball? So they are saying they asked 36 people total, and that's how they came up with this chart. And if this chart says 25% of people prefer basketball, then out of the 36 people they asked, how many prefer basketball? So I'll say that one more time because it can be a bit to take in. So we're saying we went around to 36 people, and we said do you prefer basketball, soccer, volleyball, golf, baseball, hockey, or football? And we took all this information down from 36 people. Based on this circle graph, how many of those 36 people prefer basketball? Well, we see the percent here is 25%. So we'll do it very similarly to our previous problem. But instead of 12% of 100 people, we're finding 25% of 36. Now we can multiply this. We know of means multiplication. We know this needs to be changed to a decimal. Or you could also remember this as a fraction, which may give you the tools to do it mentally. 0.12 or 25% as a fraction is 1/4, and you may be able to find 1/4 of 36 quicker. Either of these will give you the correct answer, but remember, thinking about how to do each problem wisely can give us the answer in an easier method. So what is the answer? And again, you guys are allowed to use calculators in this class now, although I don't think you need to. And you should be getting out 9, right? 9 is 1/4 of 36, as is 0.25 times 36. And so we would say 9 people out of the 36 prefer basketball. Okay, we have now made it to your homework. Your homework is 2 parts. So you're going to have another circle graph here. This is band instruments. And you're going to have a series of questions. Okay? And that's part 1. Part 2 is going to be reading another circle graph. This is from USA Today. And it's going to be a little bit different type of questions, but it's going to make you think. And this is a good exercise for reading circle graphs in everyday life, thinking about what that information means. So you have 2 parts to your homework. You are going to read this circle graph. So that's the first 6 problems. And then you're going to read this graph here. And that's the 5 more problems. So total of 11 problems. They should go pretty quick though. If you have any questions, make sure you jump onto my Zoom office hours. We'll talk to you later. Bye. All right, welcome to Tuesday, another day of creating graphs. Graphs, again, are a visual representation of information. Today we're going to focus on bar graphs. The purpose of a bar graph is to compare data. And this is really important. At the end of the week, we're going to take all of the graphs we've learned and we're going to talk about which ones are best for which situation. All right, so keep these in mind as we go through here. Bar graphs compare data. So I started off with a really basic question to get you warmed, or basic series of questions to get you warmed up. We have a graph. Now, first of all, with the bar graph, let's talk about what's happening here. First of all, we see a title. All right, that is necessary for all bar graphs. Then we see a label down here, month, and we see a label on the side, number of students. In a bar graph, we have these 2 axes. In fact, we can think of a bar graph, we've seen this a little bit before, if we have that quadrant plane again, this bar graph is really as if we just took this section out, if we took quadrant 1 out. You guys remember that, quadrant 1? It's as if we took that part and we just brought that over and dropped off 2, 3, and 4. So just looking, so think about this as X, the month as X, and the number of students as Y, right? And those are both positive. Now it's a little bit different because we don't have numbers down here. Okay, but we can think of it as that type of problem. So let's jump into answering these questions. We have the months across the bottom, number of students up the side. Number 1, which month do most students have their birthdays? Again, bar graphs compare data, and they do it really well because right when you look at that, you know the answer, and it is June. Now, if someone gave you a list of numbers that had each student in the month their birthdays in, it would take you a little bit longer. But with a bar graph, immediately we know. Number 2, which month do the fewest students have their birthday? Again, we can quickly see it is August. And number 3, what is the total number of students in the class? Well, how can we find that? Well, looking at this first bar here, first of all, we notice they're counting by evens here. So it's in between 2 and 4, which means it is 3, right? And so we're going to have to go down the line and figure out how many in each month, and then we'll add them up. So looking in February, we have 4. So come through and label this with me. Don't just watch me. You can go ahead of me and double check as I finish up. In March, I noticed 2. In April, I noticed 3. May 8, June 10, July 6, August 1, September 7, right? Because it falls in between 6 and 8, so we know it's going to be 7. October 8, November 4, and December 7. All right, so from here, to find the total number of students in the class, we are going to add them up. And you could do it in any order because of what property? I hope you remember it, because of the commutative property, right? But I'm just going to move left to right for ease of you understanding where I'm at. So 3 plus 4 is 7. 7 plus 2, 9. 9 plus 3 is 12. 12 plus 8 is 20. Answer along with me. Get it before I do. 20 plus 10 is 30. 30 plus 6, 36. 37. 37 plus 7 we know is 44. 44 plus 8 is 52. 52 plus 4 is 56. And lastly, 56 plus 7, what is it? It is 63. So there are 63 students involved in this bar graph. All right, let's move on to our next one. All right, so here you see a different type of bar graph. It is still a bar graph, but we have a double bar graph. Notice again, we have the title, minutes of homework. We have the label along the bottom. These are categories, just like we had categories before. Here, this is teachers. Okay, so we have Miss Smith, Mrs. Williams, Miss Jones, and Mrs. Brown. And then number of minutes. So this is minutes of homework. So we're assuming that this is the number of homework or minutes that they're assigning. And then we see this key over here. The key is important. If we have a double bar graph, we must have a key. And again, this is black and white, but we can understand, right? The darker gray is Wednesday, the lighter gray is Thursday. And let's jump into the questions. So we are saying, and I'll just backtrack for a second. Miss Smith on Wednesday assigned 14, and Miss Smith on Thursday assigned 16. You guys see what's happening here? All right, let's look at the questions now. Number 1, who assigned the greatest number of minutes of homework? Which day? So who assigned the greatest number of minutes of homework which day? And so we're assuming in one day they assigned the greatest number of minutes of homework. And we can quickly see the bar graph is great at comparing data. It's this bar right here, which means Miss Jones on the lighter gray is Thursday, right? And how many, well, they didn't ask for how many. Okay, so it's Ms. Jones. Sorry, guys. Ms. Jones. Which day? It is Thursday. All right, moving on to number 2. Who assigned the fewest number of minutes of homework? Which day? All right, again, fewest. It would be Mrs. Brown, and that is a dark one, so it is Wednesday. And how many minutes was it, just for fun? Just for fun. Tell me which, or how many minutes it was. It was 6. Wow. Very light homework. All right, number 3. What is the average number of minutes assigned on Wednesday? All right, we're going to pull in some of what we've already learned and mix it in with this. Average is another word for what word that we've used a lot? Mean, right? They mean the same thing. Average and mean. First of all, we need to figure out the different numbers for Wednesday. So looking at Wednesday, it's the darker bar. So for Ms. Smith, she assigned 14. For Mrs. Williams, she assigned 14, very popular. Ms. Jones, she assigned 16. Again, we're just looking at Wednesday, not Thursday. Mrs. Brown, she assigned, we already said, 6 minutes. So we have the numbers 14, 14, 16, and 6. How do we find the mean or the average of these numbers? You guys should know this. We add them up, right, and divide by the quantity or the number of numbers. So there are 4 numbers here, so we'll divide by 4. So we'll show you that here. 14 plus 14 plus 16 plus 6, and it's divided by 4 here. All right, I think we should use that commutative property because it'll make it a lot easier here. Because those 4s and 6s we know go to 10s and we can carry the 1 and it'll simplify things. So let's use that property here. So I'm going to do, we'll do 14 and we'll do 16. So 14 and 16, we know 4 and 6 give us 10, carry the 1, 1, 1, and that carried 1 is 30. And you guys can write this out. We're just using some of those properties we've learned to help us save time. So 14 and 16 combine to 30. So I'll just jot that off over here. And then 14 and 6 combine to 20, right? And we know 30 and 20 is 50. And we have 50 divided by 4. Again, you guys can use calculators. I'm going to show the work on here. Nothing too complicated. 50 divided by 4. 4 goes into 5 once. 4 times 1, 4. We subtract. We're left with 1. We bring our 0 down. 4 goes into 10. And you guys can get ahead of me. That's great. And come back and check it when I finish. It goes in there twice. We know 4 times 2 is 8. We subtract. We're left with 2. We are not going to leave it with a remainder. So we add a decimal point and a 0. Bring it down. 4 goes into 20 5 times. And it does go evenly. The answer is not 125 though. We bring that decimal point straight up to have 12.5. So we would say that the average number of minutes, oops, lost my decimal point there, is 12 and a half or 12.5 minutes. All right, so that's the double bar graph. It's a great way to compare multiple sets of data. So we can compare Wednesday and Thursday. And we can have triple bar graphs and so on from there. All right, so we have made it to your homework. Your homework's a little bit different today. Today you are going to make me a bar graph to show me what you have learned. And then you're also going to read a bar graph, similar to the one you had yesterday. I'm going to help you get this bar graph set up though. I'm going to make a few reminders and then I'll let you take the rest of it. So first of all, I kept pointing out 3 things. I kept pointing out the title, and then I kept pointing out the 2 axes down here and on the side. Now I do want to point out you can have bar graphs that run side to side like this, okay? I mean, you can see just by tipping it like I did there, we basically have it. I would probably switch the labels around a little bit, but that's what it is. We'll be making this bar graph up and down or vertically. So let's first title it, and I might not do all of it, but I'll kind of get you started. I look over here in my information. It says construct a double bar graph from the following data. Use an increment of 2. Okay, so I think what they're saying there is if we look back over here on our previous example, number of minutes, notice they counted by here by 2s here as well. So that's what they're saying. We want to use an increment of 2. All right, so you guys are going to use an increment of 2 here. We see we have these different grades and we have the number of females and males. Okay, and so we're going to use a double bar graph to show this. So first of all, you're going to title it what? The title is given to you. Okay, so I'm just going to ask you questions, make you think, so you're ready to go. The title is given to you, and then you should have your axes labeled. All right, we're going to label the axes, and I'm going to help you with those. So along the bottom, we should have the categories. What are the categories here? The categories are the grades, right? So you'll list those categories, oops, along the bottom. Now up on the side, what is this label? They didn't write it anywhere on this paper, but we should be able to figure it out. We're comparing grades with what? The female and male, that's going to be the double bar graph portion. So that's not what goes on the side, right? What could be used? What wording could be used? I want you to think. We could use number of students. Whoa. Yikes, that got messy fast. All right, yours is going to look a lot better than mine. Number of students. And they said to use increments of 2. I'm going to leave the rest for you to do. The only thing I want to remind you, you must have a key. So if you need to write that down to remind yourself, you must have a key. So don't forget that. So you have 2 parts. Construct a double bar graph. I got you a little head start there. And then I want you to read a bar graph. And that is what we'll do for Tuesday. All right, welcome to Wednesday. We are learning about another type of graphing. Remember, graphing is just a visual representation of information. Today we're going to look at line graphs. Now, line graphs have a very unique purpose. Line graphs show data over time. That is so key. They are most useful to show things over time. All right, so keep that in mind. When we get to Friday, we're going to start comparing all these graphs, and you're going to want to remember this. So, looking at this graph here, we notice these same axes like we had before, days of the week here and temperature. All right, so we kind of have categories in a way down here, but really it's more of a time, okay? So we talked about over time, and now we have this numerical portion here. So looking at our line graph, let's talk about what is happening here. Number one, which day of the week was the warmest? So looking here, again, these do a great job of showing us. We don't have to look at all the numbers. We can quickly see which day was the warmest. Well, it was the highest one, right? Which was Monday. Okay? How much did the temperature increase between Thursday and Saturday? All right, so Thursday's here. Saturday's here. We want to know how much did it increase? Well, we could do this a few different ways. I'm just going to look and see, well, Thursday was 19 degrees, and Saturday was 27. So how can we figure out the amount of increase? If you think you know what you're doing, go ahead and move on and find the answer to number two. Let's talk a little bit more about it. To get from 19 to 27, we can use subtraction, right? So 27 minus 19, or we can just count from 19 to 27, and we should be able, if we want to borrow, you can. We should see that it's going to be 8, right? So the temperature rose 8 degrees. And by the way, notice this is Celsius, okay? That's why it's such low temperatures there and a small change. All right, between what days did the temperature decrease? Between what days did the temperature decrease? Well, not a decrease here. Decrease, 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 increase, increase. All right, so from here to here, which would be Monday to Thursday. So I'll write Monday through Thursday. And we've read our first line graph. Again, starting off pretty basic, getting us warmed up, thinking about line graphs, showing data over time. All right, moving, now we're gonna construct a line graph, okay? So let's do it. So, everything's pretty mapped out for us here. We're gonna draw a line graph, and it's another temperature one. Line graphs do really well with anything over time, and apparently we're doing two with temperature. So, first we create our points. Now with the scatter plot that we learned about last week, a lot of you connected your points into lines, which was incorrect, and I noted that. Now is the time for you to shine. We are gonna connect them. January 5th, the temperature is 30 degrees. So, January 5th, right? 30 degrees, we're gonna go up to 30 degrees and make a point. Make all of your points, and then we'll talk about connecting them at the end. January 6th, which is right here along the bottom, it's 35 degrees. Now, there is not a number that says 35, but exactly halfway between 30 and 40 is 35. All right, January 7th is 40 degrees. And we'll just continue making these points, and you can get ahead of me if you want to, and then check back and see if it matches. January 8th, 40 degrees. And January 9th is 25 degrees. All right, once we have our points made, we can connect them into our line graph. Now be careful. I have some students connect this line back here. This really would be January 4th. Do we know the temperature of January 4th? No, so you cannot draw a line past back here. We can connect forward though, because we know the temperature rose from here to here, and make these straight. Don't make it into a curved portion. Between each 2 points should be a straight line as much as possible. Between these 2 points is another straight line. We have a little bit of a plateau here, and then it drops back down. And there's our line graph. All right, we have a double line graph. Looking here, and it's very hard to tell the difference in color. I will let you know, I'll mark it on here so you guys can see it. So the blue is going to be the male, okay? And this top line represents the male. Okay, so if you had it in black and white too, you can see what's happening. So the blue one is the male, and then the one I left gray is female. Okay, so let's jump into reading this. So first of all, I noticed the title, factory employees. These are the years. Just like we talked about, line graphs do really well with data over time. So we look across these years, number of employees. So they're saying in 2003, there were 150 female employees, right? This darker one is female employees, and up here, 300 male employees. Okay, so we can see how the number of males and female employees have changed over the years. First of all, number one, which year had the greatest number of female employees? Which year had the greatest number of female employees? Well, we know this line represents female employees, and the highest point is right here. And so which year was that? Well, that was 2006. Okay. Let's move to number two. How many employees worked in the year 2003? Well, looking here, 2003, we see these 2 points here. We actually kind of just talked about them. And in 2003, there were 300 male employees. And in 2003, there were 150 female employees. So to figure out how many employees worked that year, we would simply add, and this should be a mental add. If not, you can write it out, but we get 450 employees. All right, number three, which year had 225 male and female employees all together? So if we added up the male and female employees together, we would have exactly 225. So first of all, if there's 300 male employees this year, is there any way we could add 150 and 300 and get something at 225? No. So we can kind of look here and see if any of this is reasonable. All right, so already 300 not happening. 225, well, that's already at 225. If we add 75 on, that's going to go over. We're getting up higher, so 450 definitely not going to work. 375 not going to work. 300 still not going to work. So we've only got 1 year left. Let's just double check that this is right. So there are 150 male employees, right? And 75 female employees. Do 150 and 75 combine to 225? Yes. So the answer is which year, or the question is which year. So the answer is 2008. The nice thing about working on worksheets and not our textbook is that we can write all over it. So feel free to do that. Number four, what is the difference between the number of male and female employees during the year 2004? Well, in 2004, there were 225. We remember that blue is the males. And there are 75 females. And the question was what? What is the difference between the number of male and female employees during the year 2004? Difference means subtraction. So we're going to subtract these two, 225 and 75. Okay, 5 minus 5 is 0. We borrow. 12 minus 7 is 5, and we get 150. Last one, and I kind of wrote on the question, but I think you can still read it or read it on your own paper. Between what years did the number of female employees decrease? So between what years did the number of female employees decrease? Well, we look at right here, and that's a decrease, right? So we would say from 2003 to 2004. And then were there any other decreases? So this is a decrease, increase, increase, decrease, decrease. So we could say from 2006, now we could say 2006 to 2007, but really the decrease goes all the way to 2008. So we'd say 2006 to 2008. And that is reading a double line graph. All right, so we made it to our homework. You will notice you have a problem here. I'm going to read it to you, and then we're going to talk about you getting it set up, but I'll leave the rest for you. It says, the Island Middle School and the Eden Middle School collect all the aluminum beverage cans for recycling them at the end of the year. The data shows the weight of cans in pounds recycled from 2008 to 2013. Data over time. This is going to work well, right? Read the data carefully. Make an appropriate scale and draw a double line graph. Also label the axes and write a title for the graph. So you're going to title it, okay? You are going to label these axes, and you're going to pick an increment that will work here. You are not going to be able to count by ones, are you? Okay, these are in hundreds, so maybe that's a hint. The other thing, let's just talk about what this means, what they're saying they collected. They're saying in 2008, this school collected 700 pounds of aluminum beverage cans, and this school collected 500 pounds of the cans, and 600 pounds of the cans, and 400 pounds, okay? So that's what this chart is saying. You're going to represent it with a line graph. Don't forget, again, you need a key. Okay, so just like we had the little key here, and I had to kind of fix it for you, but we can see, oh, the blue line represents the male, so you need to show me what represents what. So you're going to need to use two different colors here, okay? So make sure you're doing that. And that is the end of Wednesday. All right, we made it to Thursday, which is the last day we're going to learn about a new graph, which is unbelievable. Tomorrow we're going to review all of the graphs we have learned. So without further ado, let's talk about histograms. Now histograms are very different. Some of you have learned about them, but not all of you have. If we look, this is a histogram right here. This is a bar graph, and a lot of students say, well, aren't they the same thing? No, and that's what we're going to distinguish right away, because that's where most of the struggle comes in. Students treat histograms like bar graphs, but they are not the same. Here is the biggest difference. In a bar graph, along the bottom, we have categories. So here they used USA, India, UK, New Zealand, and Japan. And they said whatever this means. Okay, categories, countries, okay? Notice also there were gaps. That is a part of creating a bar graph. There must be gaps. When we look at histograms, we notice, first of all, no gaps. And we do not see categories here. We see number ranges. Okay, so we would say here, there are 20 that range from 1 to 150. Okay? Histograms do not use categories. They use number ranges. Histograms represent one set of data where this is broken into categories. So I think it'll make more sense when we see an example, so let's do that now. Okay, so we've been given a histogram. Again, along the bottom, we do not have categories, we have number ranges. So they have 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. So we are looking here, you can see along the bottom it says miles per gallon and the frequency. So there are 15 cars. Okay, and I think they should have put that as part of their title here, or as part of their axes, or in their title. They don't have a title, but we can still work with it. So they're saying that 15 cars average 5 to 10 miles per gallon, 20 cars average 10 to 15, and so on, okay? So we don't see the exact numbers here, but we get number ranges. So first of all, our question is, how many cars are represented? Well, let's total up each bar within this histogram. So first of all, there are 15 cars in the first one. There are 20 in the second, in the range from 10 to 15. From 15 to 20, there are 35, right? In 20 to 25, there are 25. And in 25 to 30, there are 15. So to find the total, we're gonna add them all up. So let's do it. We can do it in any order. I think I'll just go left to right. So 15 and 20 gives me 35. 35 and 35 give me 70. 70 and 25 give me 95. And 95 and 15 give me 110. So there are 110 cars represented. Number 2, how many have an MPG, or miles per gallon, between 15 and 20 miles per gallon? So looking at the range of 15 to 20, you should see it right here, 15 to 20. How many cars fit that? Well, we labeled it already, 35. Number 3, how many cars have an MPG of more than 20 miles per gallon? Well, where's 20? It's right here. So how many cars fit this description? Well, here's 25 cars, and here's 15 more. So when we combine them, we get 40 cars. All right, so now They've trusted us enough to actually make our own histogram. That's exciting. So let's do it. First of all, we need to create our intervals. Now you see here it's 0 to 5, 5 to 10, 10 to 15. So we're counting by fives. So what I'm going to do in my chart is I'm going to set up my interval. So 0 to 5. And really, we'll do one less than that because 5 will be included in the next group. So 0 to 4. And then we have 5 to 9. Oh boy. And then we have 10 to 14. And then we have 15 to 20. 15 to 19, yikes. 15 to 19. And I want to point out, you might say, well, what's going on right now? We are counting by fives, but we started at 0, right? So this will encompass everything 0 to 4, and then we hit 5, so it'll be 5 to 9, and then 10 to 14, and then 15 to 19, and then 20 to 24. And if anything goes past that, I don't think anything does. So we're going to count up the number of numbers that fit within this, okay? So first of all, what is this problem talking about? A store counted how many hamburgers they sold each hour for 50 hours. So for 1 hour, they sold 1 hamburger. For the next hour, they sold 10 hamburgers. The next hour, they sold 18 hamburgers. Next hour, they sold 14. So first interval we have is 0 to 4. So let's count up the number of numbers that fall within that. So I'm just going to cross them off as I use them so that I don't double count anything. So we have 1, 2, 3, and that's all she wrote. So there are 3 numbers that fall in this interval. Then let's move 5 to 9. And again, I'm just going to move through it systematically, crossing them off if I find any. 1, 2, 3, 4, 5, 6, 7, and that's it. All right, 10 to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Moving to 15 to 19. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh no, did we forget one? All right, let's finish this and then we'll come back and add it. All right, so we had 12, 13, 14, 15, 16, 17, 18, 19. All right, and this 14 we forgot to get fits in this interval, so there was actually 15 here. All right, and then 20 to 24, we have 1, and we have 2, 3, 4. I'm just circling them so they look different because it's starting to all blend in for me. 5, 6. Okay, and to double check that I didn't miss any, I'm going to quick add my frequency up. It should total 50 hours, right? So 3 and 7 gives me 10. 10 and 15 give me 25. And what's 19 and 6? 25 as well, right? So we know 25 and 25 would give us 50. So we got them all accounted for. Let's go over and make this long-awaited histogram. So here's what we're going to do. Remember, the bars in histograms must touch. Okay, so I'm just going to make the tops of all of my bars, and then I'll come back and fill it in. So in the interval 0 to 4, we have 3. So I'm going to go up to 3, top that off, and I'll come down. And then 5 to 9, we have 7, so I'll go up to 7. Now, we can't do exactly 7, right? So it's 6, 7, 8, 9, so it's going to be a little bit closer to 6, right? We're counting by 3s here. And again, those bars are touching. And then 10 to 14 has 15, so we'll go all the way up here. Using a straight edge would be helpful. 15 to 19. Right here, 15 to 19, there were 19, so it's going to go actually a little above 18 here. Oh boy. And that's why we always use pencil, right? All right, 20 to 24, we have 6. So we're going to go up to 6 and down. We have them touching. That's great. It shows that it's a continuous set of data. All we have to do now is just shade them in. And again, they are touching. In that bar graph, they would not be touching. So that's one difference here. And we have created a histogram. Using those intervals, right? That's an important part of it. So today, in your homework, you are going to create a histogram. So this is similar to the one we just did. This is the number of ice creams sold over a 50-day period. Okay, so the first day was not a great day for business. 0. You're going to construct a frequency table using class intervals of 0, 10, 20. Don't worry, I helped you. And construct a histogram. So you're going to take this information, and you can see I already set up your intervals. You're going to find the frequency. So I would recommend doing the crossing off or some sort of organized method of moving the data over to your frequency. And then you are going to create your histogram. Remember, when you're creating that histogram, it's going to need those 2 axes labeled. It's going to need something down here and something on the side. So if this is hamburger sales, then maybe we could say ice cream sales. And instead of counting by 5s, you're going to be counting by 10s, right? And then on the side, you're going to have your frequency. So you're going to pick, notice over here they counted by 3s to get it to fit. You're going to pick whatever is necessary, okay? And you're going to create a histogram. This is your only assignment for today, and it may take you, I would recommend using a pencil at least at the beginning when you're creating your histogram, and use that homework problem we did together, or that notes problem we did together as a guide, because it's very helpful. So without further ado, this is your homework. Get started. All right, welcome to Friday. I decided to do this presentation face-to-face as there is no computation in this assignment. It's all going to be just word answers looking at different graphs. And so you should have your notes. If you don't have a printer, you should have them pulled up so you can see them. That's what I'm going to be talking through. I'm just going to quickly and briefly go over the notes here. We won't spend as much time with this, but this will just be a resource for you to have as we move into your project next week, and we'll talk about that when we get there. But it's important to understand, now that we have access to all these graphs, we've talked about all of them, when are they best to use? Because not every situation is every graph right for. In fact, there are certain graphs that are better for situations and others that are not. So we're going to run through this. Some of this we've talked about as we've gone through our lessons. So I'm just going to briefly go over this and let's get started. So first of all, we have pie charts. Pie charts are really good for showing how the whole is separated into parts. So looking at a whole group of people and seeing the separate parts of them. It also really works well for when data is reported in percentages because it fits really well within the pie chart. And again, we didn't learn how to construct one, but you can use different programs like Excel, or I think even Word, you can do it in that, to create pie charts. And I'm sure there's lots of online resources as well. It's not as great to compare 2 sets of data. So let's say we have the 7th grade class favorite sports and the 6th grade class favorite sports. We could. There are better ways that we could compare those two, and we'll get to that in just a second. That's also not as great when there are many categories. So a pie chart can only house so many categories. It really does best with like 5 to 10 categories. When you get too many, your pie slices start getting too small, and it doesn't really mean anything. Okay, so if there's too many categories, not a good option. The bar graph picks up a lot of those places where the pie chart is not quite as efficient. So the bar graph can be used to illustrate data in groups. Again, like we talk about categories, that's what we use our bar graph for, and it really does a great job of comparing two or more sets. The example I gave you on your notes is of a triple bar graph, right? And we could have a quadruple, we could have more, right? And it does a great job of quickly comparing that data. It's not as great, you can see when not to use it is when the data is not organized by groups. So if you don't have it in groups, it's not going to work with the bar graph. That might be better for the histogram. All right, moving to the line graph, when to use it. We talked about this a lot, and I pushed it a lot in our lesson. It illustrates change over a period of time. Any time your data shows change over time, that's the graph that's probably the best. The other thing it does well is it compares two or more data sets. Again, you can have that double line graph or triple line graph, and people can quickly see just by looking at it what is going on with the data. All right, our next graph was one we learned about a little while ago. It's the box and whisker diagram. Some things that it does great, it illustrates that 5-point summary, right? The minimum, the maximum, the middle quartile, the upper and lower quartile, right? So you can see all of those numbers very quickly. You can also compare two or more data sets. We didn't talk about this much, but if you look at the example that I gave you, you can see they gave us 3 box and whiskers, and we could quickly compare the different middle quartiles, upper maximums, minimums, all that, just by looking here. So very effective for comparing two or more data sets. And it works really well, when the data set is large. So if you have a lot of numbers, this really nicely summarizes them. It's not as helpful if the exact values need to be seen. Okay. All right, let's move to stem and leaf, another one we learned about a while ago. When to use. It's good to visually represent the range, mode, and data inconsistencies. We can keep the exact values, right? In the box and whisker, we do not see the exact values. Stem and leaf, you can see all of the numbers right there. And we can use it when the data set is large. When a stem and leaf diagram is not as effective, is when we want the central tendency measures like mean, median, mode, middle, upper, lower quartile. If we want that to be shown, the stem and leaf does not do that. So that's a weakness of it. Moving to the scatter plot. It is really effective at illustrating a relationship between two characteristics, right? We talked about it could compare height and age, right? That's one thing it can compare. So it can compare two things really well. You see the example there, days and weight. It's not as effective when the data set is large. And our final graph is the histogram, the one we learned about yesterday. Strengths, or when to use it, to clearly illustrate large amounts of data when central tendency is fairly apparent. Okay, it's great when the data set is large. When it's not as great is when exact values are important, right? Because we just have ranges here, so it's very general and it's not as specific. The other area it's not as great is it's not great to compare two or more data sets, right? We talked about a double bar graph or a triple bar graph. It's really great at comparing multiple sets of data. Histogram, not so much. It's good to show one set of data. So that is an overview. And again, this is a good resource for you. Hang on to this. I know I just skimmed over that, but that should kind of just jog your memory. I emphasized some of those points as we went through there, and some of them are kind of logical, right? So we're going to do 2 examples, and then I'm going to let you get started on your homework. So example 1, we are going to pick which graph is best. Now, there may be multiple choices that'll work. Typically, there's going to be one best or maybe 2 best that I would take. So example 1, which type of graph is best for comparing the achievement test scores of a student over a period of 10 years? Okay, so we're going to create a graph, and we have their scores from each of the 10 years, and we want to represent that. So thinking of our graphs, so if I flip back through here, I have pie chart, bar graph, line graph, box and whisker, stem and leaf, scatter plot, and histogram. Which do you think would be most effective? I hope you heard the words 10 years and knew automatically data over time works best in a line graph. Yeah. So because we have that issue of time there, a line graph is a great way to represent it, right? We would say in year 1 they scored this, in year 2 they scored this, and we could quickly visually see increases and decreases. All right, example number 2, which type of graph should be used to illustrate the relationship between the ages and heights of students? Whoops, I think I gave this one away. If we're trying to compare the relationship between ages of students and heights of students, how could we do that? Now we could argue different things here, but we had one graph that specifically talked about that it's great at comparing two characteristics of data. And which graph was that? If you need to flip back through, do that. I'll give it a little bit of time. It is the scatter plot, right? The scatter plot is great at comparing two characteristics of data. And here we have age and height. All right, so your homework is problems 1, 2, and 3 on the next page. You have 3 more problems like that. Which type of graph? Notice in number 3, it says which type of graph would be best for the data below? Create that graph. Okay, so the first 2 you just need to answer them. In number 3 you'll answer it and then create the graph. So don't forget to do that. That's not optional. It is required. So without further ado, you have made it to the end of the week. I hope you have a great weekend. I am so excited. We have finished week 5. So go do your homework and I will see you next week.